In the world of generative AI, stepping into a realm filled with specialized terms and concepts feels like entering a futuristic laboratory buzzing with innovation. Imagine engineers and researchers speaking in a language where words like embeddings, context windows, and tokens hold the keys to unlocking AI's remarkable abilities to create, converse, and predict. Embeddings are a foundational concept. Think of them as the digital equivalent of translating a book into a secret code that only computers can read. Each word or phrase becomes a point in a vast, multi-dimensional space, where words with similar meanings are placed closer together. For example, in this coded map, king might be near queen and ruler, while apple sits closer to fruit and tree. This technique helps AI models understand relationships between words beyond simple dictionary definitions. Continuing the journey, you come across the context window, a term that defines how much information the AI can see at any given time. Imagine you're reading a novel through a small window that only shows one page at a time. If your window is small, you might miss crucial details from previous chapters. For AI, a larger context window allows it to handle long conversations, complex documents, or detailed coding tasks without losing track. Models like GPT-4 have a much larger context window than their predecessors, making them better at maintaining coherent discussions or summarizing lengthy articles. Tokens are the building blocks of this AI-powered world. Unlike humans who see text as words or sentences, AI breaks everything into smaller pieces called tokens. A single word might be one token or multiple, depending on its complexity. For example, cat is one token, but fantastically might be split into multiple parts. Models have token limits, so managing them wisely is essential when crafting prompts for complex tasks. Speaking of prompts, these are the instructions given to AI to guide its responses. Crafting an effective prompt is akin to writing a script for a play. Specific wording leads to better performances. For instance, instead of asking, "What is a dog?" a well-crafted prompt might say, "Explain what a dog is, including its characteristics, common breeds, and role as a household pet." The latter prompt gives the model a clear direction, yielding richer and more useful answers. Transformers are the technological backbone of many modern AI systems. Think of them as advanced neural networks designed to weigh the importance of different words when generating responses. Attention mechanisms within transformers help the model focus on relevant parts of a sentence. For example, in the phrase "the cat, which was black, sat on the mat," attention mechanisms enable the model to connect cat and sat directly despite the descriptive phrase in between. Pre-training and fine-tuning are akin to education phases for AI models. During pre-training, the model reads massive amounts of data from books, websites, and more, learning general patterns in language. Fine-tuning narrows its focus, teaching it specific skills. A pre-trained model might understand general language, but after fine-tuning on medical data, it becomes adept at answering healthcare-related questions. Reinforcement learning plays a role in refining the model's responses. This involves feedback from human trainers who rank or score answers, guiding the model toward better behavior over time. It's like a teacher providing corrections to improve a student's essays. OpenAI's models, for example, were fine-tuned using reinforcement learning with human feedback, RLHF, to align responses with human preferences. When someone mentions zero-shot, few-shot, and one-shot learning, they're talking about how much information the AI needs to learn a task. Zero-shot learning means the AI performs a task without any examples. Imagine asking a model to translate a sentence into a rare language it's never seen before. It might still get it right based on general knowledge. Few-shot learning involves giving a handful of examples, while one-shot learning manages with just a single instance. Latency measures the time it takes for the AI to respond. This is crucial for applications like voice assistants or live chatbots, where users expect near-instant answers. Reducing latency requires optimizing the model and its deployment environment. Hallucination is one of AI's quirks. It describes moments when the model confidently generates false information. Ask an AI about a fictional historical event, and it might invent a detailed but entirely fabricated story. These hallucinations highlight both the creative potential and limitations of generative models. Diffusion models, a hot topic in image generation, work by starting with random noise and gradually refining it into recognizable images. This approach underpins tools like DALL-E and Stable Diffusion, which can create stunning visuals from simple text descriptions. Attention mechanisms, beyond their role in transformers, are like spotlight operators in a theater. They ensure that the AI focuses on the most critical parts of a sentence or image, enabling more accurate predictions and coherent responses. Transfer learning allows AI models to apply knowledge gained from one task to another. For instance, a model trained on general English text can quickly adapt to understanding legal documents with minimal additional training. Ethical considerations like bias and alignment are ever present in discussions about generative AI. Developers strive to reduce biases that can creep into AI outputs and ensure that models behave ethically and align with human values. This involves careful training, diverse datasets, and ongoing evaluation. As you walk through this dynamic world, it becomes clear that terms like embeddings, tokens, prompts, and context windows aren't just technical jargon. They're the gears and cogs of a machine shaping how humans and AI collaborate. With every concept understood, a new layer of creativity and innovation unfolds, propelling us further into a future powered by intelligent systems.